Welcome back. Now, 12th class, third chapter, fifth session. It's about Drude's formula. We actually say Drude's formula. Drude's formula. It's not mentioned its name in our textbook. Still, Drude's formula. Let's see how it happens. You remember one equation for current I equal to NEA VD, right? I equal to NEA VD. Now what is VD? VD equal to EE by M into tau. EE by M into tau. So let's substitute it there. So I equal to NEA into EE by M into tau. So what happens? I equal to N E square A E tau by M. N E square A E tau by M. That's it. That's it. This is the equation for current. Now, already we know electric field is related with potential difference as electric field is equal to V by L. You remember E equal to dV by dr? You remember that? Is equal to potential difference divided by perpendicular distance. There was one equation like that. In potential we studied it. So how can you substitute it here? I equal to NE square A tau by M into V by L, isn't it? Okay, that's all. Now, what is V by I? What is V by I? V by I will be Lm, isn't it? Divided by Ne square A tau. So simple. V by I equal to Lm divided by Ne square A tau. And you know what V by I is? V by I is nothing but the resistance. So R is equal to Lm divided by Ne square A tau. And I already give one example for equation for resistance R equal to rho L by A. Now let's substitute this R over here. You are getting rho L by A equal to ML divided by Ne square A tau. Now what happens? LL cancels, AA cancels. So resistivity is equal to M by Ne square tau. This is what we call it as the Drude's formula, which is the equation for the resistivity. Equation for resistivity in terms of mass of electron, number of charge carriers per unit volume, charge of electron, and relaxation time. And see, we have something more to say about this equation, which is very important in the examination point of view. You have to write it as notes, listening to my explanation, right? So the equation is R equal to M by Ne square tau. You have to understand what M. M is the mass of electron. N is the number of charge carriers per unit volume. E is the electronic charge. And tau is the relaxation time. Relaxation time means time difference between two successive collisions. Now let's see. In the case of conductors or metals, we can say metals. For conductors or metals, we say they have got positive temperature coefficient of resistance. What is the sentence? For conductors or metals, they have got positive temperature coefficient of resistance. What do you mean by that? The meaning is for conductors and metals, or conductors or metals, when temperature increases, resistance increases. That is what the positive temperature coefficient of resistance means. I will repeat. When temperature increases, resistance also increases. Why? That's a question. Let's explain it. One thing you are very sure about, that R equal to rho L by A. So when temperature increases, there is no much variation in length and area. Definitely there is expansion of conduction happening, and that is there, but that is very microscopical variation that we are not considering here. So the resistance increases because of resistivity increases. It means what? Temperature increases, resistance increases because resistivity increases. Why? I told you rho equal to m by ne square 2. When temperature increases, what happens? When temperature increases, thermal agitated motion increases. The speed with which the electrons are revolving around increases. So what happens? The probability of collision increases, right? When they are moving very randomly, very fast, the probability of collision increases. Do you remember what was tau? Tau is the relaxation time, which means that is the time between two successive collisions. So if the speed of motion increases, the collision becomes very probable. The probability of collision increases. So the time difference between two successive collisions decreases. So we say when temperature increases, tau decreases, means possibility of collision increases. Therefore, resistivity increases. So when resistivity increases, resistance also increases. That is the reason for increasing the resistance or resistivity when temperature increases for conductors. Next is the case with insulators. Insulators have got negative temperature coefficient of resistance, we say. Insulators have got negative temperature coefficient of resistance. That means when temperature increases, resistance decreases. Why? Because when temperature increases, resistivity decreases, so resistance decreases. That is the reason. Now we'll see how it happens. What happens here is when temperature increases, what do you mean by this, small n? So rho is equal to m by ne square 2, right? M by ne square 2. So this m is the mass and n is the number of charge carriers per unit volume, and E is the electronic charge and tau is the relaxation time. When temperature increases, what happens? More and more electrons get freed. More and more electrons get freed. So n increases. So when temperature increases, n increases. Why? Because more and more electrons are get freed. So what happens? When n increases, resistivity decreases. Now you may ask one question. So the same argument what we told for relaxation time is applicable here also. But my answer is no. Why? Because actually that is happening. That is happening. When temperature increases, resistivity here also decreases. But the thing is, the effect of increasing the number of electrons per unit volume is more than the effect of tau. So ultimately, the increase in n is the decision maker. So the resistivity decreases. Next is the case with the semiconductors. Next is the same case with the semiconductors. So this one we will explain very elaborately in last chapter of our +2. But here I will just give you something. And for semiconductors, we say there are two different types of situations for electrons. One we call it as valence electrons or valence band, and the other is conducting electrons or conduction band. Actually, at 0 Kelvin, the electrons will be there in the valence band. When temperature increases, electrons will be moving to valence band to conduction band. And these conduction electrons are responsible for conduction of electricity. And when electrons are jumping to conduction band, there develops a hole, the deficiency of electron. And due to hole and electron, conduction is happening. So when temperature increases, so the conduction is due to both electrons and holes in case of semiconductors. So what happens? When temperature increases, more and more electrons are shifted to conduction band. So if more and more electrons are shifted to conduction band, what happens? N increases. Number of charge carriers per unit volume increases. N increases. So temperature increases, N increases, resistivity decreases. So this is what the resistivity is. This part that I explained here is very important for thinking type question or hot based questions and all. This one is a question asked in the derivation type questions, right? That's all.